Let us try to understand the forces acting on a car when it is moving around the curved road. The road is flat, that is not banked. The gravitational force, mg, is always down. Road exerts a normal force. Normal force is outward and always perpendicular to surface. When this car moves around a curve, it needs centripetal force, which comes from friction force of tire on the road. So totally, there are three forces acting on the car. Friction is static friction, because the part of rolling tire that is in contact with the road is at rest. This may seem odd, but think a little and it is true. Of course, we assume that the tire is not slipping. During the rain, the road gets wet, and then the coefficient of static friction decreases, so we have to slow down as the friction cannot provide the centripetal force. There is workaround, that is, friction is not needed to go around the curved road. This is instead done by banking of the road. Before we discuss the science of banking, let us show you some pictures. Racing cars don't want to slow down, and friction almost certainly cannot provide the centripetal force, so they run on banked road. The rail tracks are also banked because train can move with high speed unhindered. Many of the road are banked, and recommended speed is posted so that car can travel fast in wet or dry road. Otherwise, the car need to slow down in road that is sandy or during the rain. Now, let us do the physics of banking the road. Let us find how many forces are acting on the car. The gravity mg always acts down, and normal for road is reaction force. The normal force is acting outward and perpendicular to the surface. We chose our coordinates such that x is in horizontal direction and y is in vertical direction. Here part of n, which is n cos theta, is equal to m times g, and n sine theta provided for the centripetal force. Here the question you may have is why, when we solve inclination problems, we have n equals mge cos theta, but here we have n cos theta equals mg. Answer is quite simple. We choose the coordinate system where the y had pure translation force, that is n cos theta, is always vertical, and m times g is always vertically downward. The n sine theta is continuously moving to the center of curvature of road, or in other words, in this coordinate system, the horizontal plane has the pure circular force, which is motion of car, is continuously moving the part of n towards the center of curvature. Our choice of coordinate system has purely separated the translation part in vertical direction and pure rotation part in horizontal plane. Pause this video and think about it till you are convinced. Now it is simple. Divide the two equations and get tan theta equals v squared by r times g. See that it does not need friction if you have the right speed, depending on the banking angle. I hope this video showed importance of choosing the right coordinates and banking of the road. We will end the video here. Please write in comments if you have any question. Bye-bye.